In this lecture we will study complement of the DFA. Now DFA is 5 tuple. If you are given a DFA M Q sigma delta Q0 F, then complement of the DFA denoted like this, M complement. For M complement, set of states Q will remain the same, input alphabet will remain the same, transition function delta and initial state Q0, that will also remain the same. The only thing that is going to change is set of final states. So here for M complement, set of final states will be Q minus F. We will understand this using one example. Consider this DFA M. So in this DFA, states A and B, they are final states. So this is set of states Q. It contains A, B, C and D states in M. Final state, they are A and B. So Q minus F, we will subtract this set from this set. We get Q minus F as C and D. So in M complement, we will mark only C and D as final states. So all the states are same, transition function is same. The only thing going to change is we will mark Q minus F, C and D as final states. So what happens when we change final states from F to Q minus F? So every final state in M will become non-final state in M complement. Every non-final state in M will become final state in M complement. Here A and B are final, they are non-final in M complement. Here C and D are non-final, they are final in M complement. So what is significance of complement of the DFA? Now consider a string W which belongs to language of the DFA M. Now when we say a string belongs to language of the DFA, processing of the string ends in some final state. Now for that same string, processing in M complement will end in non-final state. The state will be same, but here it is final, here it is non-final. So if W belongs to L of M, then W does not belong to L of M complement. In M, processing is ending in final state. In M complement, processing is ending in non-final state. And similarly, if W does not belong to L of M, then W belongs to L of M complement. If processing of W ends in non-final state in M, then processing of W will end in final state in M complement. Every string rejected by M is accepted by M complement. Every string rejected by M is accepted by M complement. So language of complement of the DFA is equal to complement of language of the DFA. If L1 equal to L of M, L2 equal to L of M complement, then L1 is complement of L2. So complement of the DFA recognizes complement of language of the DFA. Now based on this, there are some simple logical results. Now for language L, if you design some DFA M, it may be minimal, it may not be minimal. Now we want to design DFA for L complement. So now we do not have to apply some extra logic, or we do not need to take any extra effort. We simply take complement of M, we change final states to non-final and non-final states to final, and this DFA M complement, it will recognize language L complement. On the similar lines, if M is minimal DFA for L, then M complement will be minimal DFA for L complement. And again on the similar lines, for language L, if minimal DFA contains n number of states, then for language L complement also minimal DFA will contain n number of states. So these are simple results, but they are important from exam point of view. During exam, you should not spend time in deriving these results. You should use these results readily for solving the problem. Now let's see few more examples for complement of the DFA. Consider alphabet contains only one symbol A. Language L is W such that number of A's in W mod 3 is 0. So this is the DFA. Here number of A mod 3 is 0. Here it is 1. Here it is 2. Now complement of this language will be W such that number of A mod 3 is not equal to 0. So we take the same DFA. States are as it is, PQR, PQR. Transitions are exactly same. The only thing we are going to change is every final state over here will be non-final state here, and every non-final over here will be final state in M complement. So for Q we have to mark it as final state. For R we have to mark it as final state. P is final in DFA of L. It will be non-final for M complement. So here number of A mod 3 is 0, it is non-final. For Q number of A mod 3 is 1. For R number of A mod 3 is 2, and they are final states. So this DFA is complement of this DFA. So we get DFA for L complement. Now consider L equal to sigma star, and this is the minimal DFA for sigma star. We take one state and here we accept all the strings. Now for L complement will be empty string. Sigma star contains all the strings. Phi is empty set. Sorry, not empty string, empty set. Phi is empty set. Now for complement of the DFA, we take same state P. Here it is final state. Here we keep it as non-final state. So here P will act as a dead state or a trap state, and every string is rejected. So this is minimal DFA for phi. Now consider L equal to singleton set containing epsilon. So we take state P and Q. So epsilon is accepted in initial state. Epsilon is part of the language. Initial state is final state. And then every other string is rejected in state Q. Q is trap state. So for complement, if L is equal to singleton set containing epsilon, L complement is sigma plus. Sigma star minus epsilon is sigma plus. So again we take same DFA. States are same, transitions are same. P is final over here, it will be non-final over here. Q is non-final, here we mark it as final state. So epsilon is not accepted by this DFA. Initial state is non-final state, and every other state string is accepted in state Q. So this is how we can use complement of the DFA to calculate DFA for complement of the language. The concept of complement of the DFA can also be used for building the DFA, because sometimes it may happen that for the given language description, building the DFA directly for the given language may be difficult compared to building DFA for complement of the language. Take one example. Alphabet contains A and B, and language L is W such that W does not end with AB. Now if we try to design DFA directly for this language, then it will be more difficult. We already have studied how to build DFA for ends with condition. So if L is W does not end with AB, L complement is W ends with AB. And this is the DFA. We already have studied how to design DFA for W ends with condition. So this is DFA for L complement. This is M complement. Now to get DFA for L, we simply have to take complement of this DFA. So we take the same states, and now we do not apply any extra logic. We simply copy the transitions. So A, B, and now non-final states here will become final states in this DFA, and final states over here will be non-final states in this DFA. So this is the DFA for given language. This is DFA for W such that W does not end with AB. Now if you are using this strategy, remember that first you are designing M complement. First you are designing DFA for L complement. So you have to remember to take complement of M complement, and this is the DFA for language L. If you forget this step, then your answer may go wrong. So remember this step. Now finally some important points related to complement of the DFA. First thing, when we consider complement of the DFA, we change F to Q minus F. So you have to change all final states to non-final states and all non-final states to final state. You cannot skip any state while making the changes. That is first thing. Second thing is, complement of the DFA recognizes complement of the language. This is true only for DFA. This may or may not be true for NFAs. So consider this example. This is NFA. In this lecture series we have not studied NFA, but considering complement of the DFA, this is important. Now this is NFA, this is not DFA. Here we do not have transition for B. So this NFA rejects string B. If we take complement of the NFA, here transitions are same. We just change non-final states to final states and final states to non-final states. So here also string B is rejected. This is M complement of NFA M. This NFA also rejects string B. This NFA also rejects string B. So in case of NFA, language of complement of the NFA may or may not be equal to complement of language of the NFA M. And this third point we already have studied, but it is important one. For a given language L, if minimal DFA contains n number of states, then for complement of the language also minimal DFA contains n number of states.